Hello, my name is Mira, and here's a quick recap of my project and updates. I'm creating a series of sustainable evaporative cooling systems, which are essentially natural air coolers. In Bali's intense heat and humidity, I set out to explore whether we can cool using only natural materials like bamboo and terracotta. While researching evaporative cooling, I discovered almost no studies exist for how they perform in humid climates. And for a moment, I felt like my project might not work. But that gap is exactly why this matters. I decided to build a series of evaporative cooling systems, testing them in different environments, such as humid Bali, Indonesia, and during the dry season in Goa, India, to understand how these systems really perform under different conditions, and using the data to guide future designs and write a research paper. Here's how it works. When water evaporates, the change from liquid to air requires energy, and the energy it absorbs comes from the heat in the surrounding air. So as the water molecules escape into the air, they take that heat with them, leaving the air behind cooler. Once I started building my prototypes, nothing went smoothly. My first metal frame took ages to weld, so I switched to bamboo for the second one, with help from the school carpenters. I also tried making terracotta tubes myself with some friends, but they didn't come out quite great, so I sourced proper ones from local potters instead. Using scrap bamboo from around green school and lots of improvising, I finally had 2 frames ready. Slowly, the prototypes began taking shape. Assembling the prototypes brought even more challenges: misaligned pipes, leaks, splashing water, and struggling to find a water tray that fit. With help from the iHub, I repurposed an old wooden box as the water tray and made holes into upcycled pipes, sealed gaps, and retested everything again and again. After countless fixes and tweaks, the system finally came together and was ready for testing. After 2 weeks of collecting data with temperature and humidity sensors and a sling wet bulb thermometer, I found that the evaporative coolers reduced temperature by around 2 to 3 degrees Celsius, even in Bali's far from ideal, rainy, humid conditions. This means that with some modifications and with a larger scale cooler during the drier season, it could really work quite well, even in Bali. This first test round taught me a lot and has helped me prepare for my large-scale installations, but a lot more testing is definitely to come. Then a dream came true. After months of emailing venues, hoping someone would take a chance on my project, I heard nothing. Then one follow-up email changed everything. I got accepted to exhibit my evaporative coolers at the Serendipity Arts Festival. This is the same festival I went to every year with my friends growing up, the one I always dreamed of being a part of. And now I'm in Goa, India, creating 4 large cooling leaves for South Asia's largest annual multidisciplinary arts festival, the Serendipity Arts Festival, in the perfect environment for them to reach their full potential as they work best in dry areas. I've been sharing the whole journey in detail on my Instagram, so if you're curious, feel free to check it out. And if you'd like to support this project, any contributions to my GoFundMe would mean a lot. Thank you for listening.